Welcome everyone to my channel again. So in this video we are going to see how to decide which B-side features to use in plastic parts. Many of students ask me this doubt. They cannot decide which features to use where and which factors should be considered while designing the B-side features. So here is a video for them guys. Here in this video we are going to see how to decide a B-side features, where to use which features and which factors you need to consider while designing the B-side features of the plastic. So those who are really new to this subject, those who don't know what is a B-side, what is a B-side feature, okay, so there is a little introduction to them. Okay, so the first thing is B-side refers to the opposite side of the A side. So whenever we get a styled part from the customer, that is A side, and we developed a B side out of that, and we create features to attach that plastic part to its desired location, right? So B side features are the secondary features. Okay, so you can see one of the image here, so you can understand the portion of this part below this. You can say this is the A surface. The inner portion of this part is called a B surface, and you can see there are a lot of tiny features. You can see this boss, then snap feet, then screw boss, and then these ribs. Those are all called B side features. These are B side features. Okay, so today's session is all about how to decide these features, because you want to attach that plastic part to its desired location, right? So just with the A surface and B surface, it is not possible. You have to create a B side feature. So these are the secondary features, but it is very important to understand how to decide that feature. Okay, as I said, it's important to attach plastic part at its desired location. So that is a little, we can say, introduction. Those are very new to this topic, but those guys who already know the plastic, they can understand what is the B side and B side features. Okay, now we'll see what are the types of the B-side features we are talking about. There are multiple, we can say 1,000 types, but these are the common types of the B-side features. Okay, you can see ribs. So one of the image here, the supporting ribs to strengthen the part. Okay, then boss, if you wanted to attach any screw, so you are going to create a boss something like this. Then holes will be there. Then gussets will be there. Gussets is nothing but the set of ribs, you can say. Then snaps. Okay, everyone knows about the snaps, right? Then locators, something like this to locate the part, okay, to its desired assembly position. Then doghouse, you can see this image of the doghouse, so mostly used to we can say raise the height of the feature. Okay, clip towers, you can see something like this clip tower. And live hinges. Okay, you can see this example of the live hinges. So live hinges, you know, means all the we are using the shampoo bottles, then tiffins. Okay, so those flaps are, we can say, can open and close that flap, right? So that hinge is called a live hinge, created into the plastic. So these are all the common attachments, as I said, but there are 1,000 different attachments also, different types also, but common types are, we have seen this. So now question is, these are the attachment, but now you have the plastic part, you have created, we can say, you have a solid A surface, you have created B surface out of that, and now you wanted to attach that part to its desired location. So the question is, which feature to choose out of this feature, and what is the criteria for that? Okay, so we are going to see that, and that is the main topic of today's video. Okay, so factors to consider to design B-side features. These are all the important factors. Okay, there are multiple factors other than these also, but these are the, we can say, most factors. Okay, so we'll see one by one here. The factor number one is you have to consider 3-to-1 principle. I hope everyone knows about the 3-to-1 principle. It's a very basic principle that you are going to lock your part in 3-to-1, means 3 degrees of freedom, 2 degrees of freedom, then 1 degree of freedom. That means you have to lock your part in all 6 degrees of freedom. So this is all about the 3-to-1 principle. You can see this part and you have to lock. While attaching your part should be locked. Means if, for example, you have one of the sub-assembly and you are going to attach your plastic part to that sub-assembly, right? So you should consider it's, you can say, your feature is locking 6 degrees of freedom. Okay, So while deciding the attachment, you should consider it should lock 6 degrees of freedom, need to consider the part size and shape, and it should provide the dimensional stability to the part. We'll see one of the example here. Okay, you can see this is a bumper part on the screen. You can see this. Okay, so I'll just zoom it a little bit. Yeah, so this is a bumper part. Okay, and just think logically, guys. So this is a big part onto the vehicle, right? And if you choose the attachment only on these two sides, suppose this is one attachment and here is one attachment, that's it. Whether it is really feasible, because we are attaching part here and here, but at the center it is free to move, right? If someone pulls that part from the center, then it can be easily dragged out, right? So you have to consider the degrees of freedom, how you are locking that part. Okay, so the general, we can say, concept of creating the attachment is it should create a triangle, right? If your part is bigger, I'll just show it in this next image. You can see this. So here there must be attachment, here there must be attachment, here there must be attachment. So these three attachments are must, and according to the requirement you can create extra attachments in between. That means your part is locked here, your part is locked here, your part is locked here. So you have decided the position of your attachment. Okay, and again guys, this position of attachment depends on your counterpart. Okay, I'm telling you that you should have attachment here, but parallelly you should check whether you have something there, means this part is attaching somewhere, right? So there should be, suppose you have created a snap here, but that snap is going to attach in some slot, right? And that slot should be there in your counterpart. Again, that thing also you have to think. Okay, and considering that things, your attachment should form triangle so that it will get a dimensional stability. If you attach from part from here, here and here, then it will get a dimensional stability so that it will not move, right? So that is a basic thing that you can consider while considering or while deciding the locations of the attachment. Okay, so that is the first factor. Now your locations are finalized. Okay, now decide what is there into the counterpart, if you have a hole, if you have a slot, or if you have just edge. Okay, so considering that we have other factors, ease of assembly. You have to consider the ease of assembly, how easy it is to assemble that part. Okay, just take this example. It should be easy to assemble and it should consume less time. For example, you have these multiple parts and operator is taking a lot of time, like 30 minutes to 1 hour to assemble one part. Whether it is really feasible for on the, we can say, line. Okay, it's a JIT line, just in a time they wanted to attach all the parts. And if your assembly is so complex, your attachments are so complex that operator is just taking a lot of time to assemble just single part, then that is of no use, right? So you should check ease of assembly, how easy it is to assemble that part. Okay, that is important factor and you have to consider it. Next factor is serviceability. Just consider the serviceability of the part. Okay, feature can be defined based on the serviceable or permanent part, whether your part is going to attach permanently or that part is serviceable. Just check it is like needed to just remove that part for the serviceable purpose. If that is the case, then you should design that type of the feature. Okay, I'll just show you. I'll just draw one sketch in front of you. I'll just take a graph and I'll just draw something. Okay, I'll try to draw on the screen here. Okay, so how to consider, just take an example of the snap. Okay, serviceable snap and non-serviceable snap, permanent snap. Okay, so how to design that? Okay, the shape of the snap you have to change. Now just think about the you can say serviceable snap. Okay, so this is a snap. I'll just draw a rough sketch here. The bottom of snap is, we can say, tapered so that it can be easily removed. Okay, and the counterpart, there is a slot here. So I'll just show it with the different color here. Okay, it's not getting highlighted. I'll just choose a different color. No problem. For example, this is one of the structure part and there is a slot in between, and now my snap is attached here. Okay, you can see this interface is on the tapered one, so that if you pull that part down again, the snap can be removed. So that is called a serviceable part, right? So once you attach that part, you can again remove that part for the service purpose. So that is a design of the serviceable part. But if my snap is like this, I'll just again change the color. Okay, so this is a rough sketch, guys. Just I hope you understood it. Your understanding. The bottom of snap is exact straight. That means what will happen here? Suppose this is your mating part, right? Now just imagine logically, guys, if you pull this part, the bottom is flat. If you pull this part down, because of that bottom of this snap is flat, is it really feasible whether that part can be disassembled? No, right? Here we have taper so that it can slide on the taper and it can be removed. But here it's a sharp, we can say step here, okay, flat step here, so it cannot be removed. So that is called one of the example of considering the serviceability of the part. So whether your part is permanent or whether your part is serviceable, just check that and design the feature according to that. If your part is serviceable, you should use this type of the snapping if you are using the snaps, and if your part is permanent, then you can use this type of the snapping. Okay, so I hope that is clear. Okay, next factor is a functional requirement. So before deciding the B-side features, first identify what purpose this feature should serve. Means before considering the B-side, before deciding the B-side features, just consider what is the purpose of this feature. Okay, so for example, for the electric housing, if you see the electric housing, if you see small electrical parts, right? B-side attachments might include mounting features for internal parts. There are a lot of internal parts, those are mounted on the B-side features. So you have to consider that also. What is the functional requirement of your feature? If you are designing the feature, what purpose that feature should serve. Okay, so that is the important factor. Next factor is material compatibility. So most of the times you should use exact material. Okay, material should be exactly same for the A side of the plastic and the B side of the attachment for purpose of the strong bonding. Otherwise, if you are choosing a different material, again it is very difficult to manufacture. And just consider, still if it is manufactured, then it is very difficult to create a bonding. So your plastic, we can say, attachment can separate from your main part, and which will not be the feasible one, right, for the assembly purpose. Then moldability. So guys, into the CAD software you can create anything, but whatever the features you have created, so that should be moldable, right? So this is the injection molding process generally we are using for all the plastic parts. Okay, so you should avoid undercuts, avoid a complex geometry, avoid a thin tool condition, right? So whatever the features you are creating, so this is the cuts, guys, undercuts. Okay, just try to avoid undercut. Okay, because it's increase the tooling cost. It will increase the tooling cost. It will create a complex, so we can say, manufacturing method. So just avoid that. Every time try to avoid the undercut. If you are creating the B-side features, check whether it is feasible into the main tooling direction. Okay, and avoid thin tool condition. That means if your feature is too thin, then it is very difficult to manufacture. And again, if it is manufactured, then we can say it is not a durable one. Okay, so you have to consider the moldability also while creating the features. Next important factor is aesthetics. Guys, for example, you consider all this requirements here. Okay, your B-side feature is satisfying all these 6 requirements. But because of your B-side feature, if your part is getting worst, if we are getting some of the impressions on the A side, on the style part, then we can say that part will be rejected. For example, if we know we can say defects into the plastic, right? So just consider the two defects here for we can say because of the B side feature we get that the sync mark. Okay, you can see one of the image here. So you can see this on the A surface you are getting this type of the impression. You can see this guy, this one, this one, this one. On the A surface if you get this type of the impression, so that part is going to reject because it's affecting the aesthetic of that part. Your B side feature, whatever you design, because of that B side feature, you are affecting the aesthetic look of that part, right? So while considering the B side feature, there are standards that how much should be the thickness, base thickness, and all that things. You have to consider that standard so that you will not get this type of the defects on the A surface. Okay, and again, uniform thickness should be there on the B side. Otherwise, your part will be warped. So your design will be like this, but your molded part will be like this again, which will be rejected by the customer. Okay, so this is the important factor. You should consider the aesthetic wise also. It should not affect the aesthetics. Next important factor, strength and durability. Means your aesthetic wise part is good and all the factors it is good, but your part is not, we can say, durable, because it should, we can say, it can be used for the longer period, right? It's not like you just assemble that part and your job is done. No, you should consider unexpected loading, right? So you can see this plastic part should withstand intended loads and environmental conditions without compromising its performance. So whatever the loads you are considering for that plastic part, just consider the environment condition and the intended loads, and with that loads your part should perform without, we can say, compromising. Okay, so you should consider strength and durability also while designing your B side features. Then manufacturing complexity and the cost, we almost discussed about this. Okay, complex B side features incurs the complex tools which results in the high cost of the product. For example, if you are adding all the undercuts, all the, we can say, sliders are there, then lifters are there for your B side feature, then again it will incurs the complex tool and which will result into the high cost of that product. And if your product cost is high, then customer is not going to buy that product. Correct? So you should choose a simple manufacturing method while designing the B side features. It should not be complex. Always go for simple one. And the last important factor is DFM, designed for the manufacturing. Okay, so you have to refer all the DFM guidelines for the plastic parts. DFM guidelines means designed for the manufacturing. That means uniform thickness. You have to maintain uniform thickness, wall thickness. Then you have to maintain a minimum draft angle so that tool can be removed in the tight out direction. And a lot of we can say DFM guidelines are there. Okay, we are not going to cover all the guidelines in this video, but while considering the B side features, you have to consider all the guidelines. So these are the 10 important factors, and there are multiple factors other than these also, but these are 10 most factors. Most of the B side feature you can decide based on these 10 factors. Okay, so what we have seen, I'll just repeat it again. We have seen 3-to-1 principle. Just lock your part in the 6 degrees of freedom. Then consider the ace of assembly. It should be simple to assemble. Then it should be serviceable depending on the requirement. Okay, so just define your features based on the serviceability. Then consider the functional requirement of that feature, functional requirement of that part, and based on that choose your attachment. Then just check the material compatibility. Okay, if you are choosing a rigid material for the snap, then snap should be like flexible, right? And if your material property is, we can say, rigid, then it will break, right? So you have to consider that type of the material there and the feature there. Then it should be moldable. It should be easy to, we can say, mold that part. Then it should not affect the aesthetic look of the part beside feature, right? Then it should be having the good strength and the durable. Then you should consider the manufacturing complexity and the cost incurred for the manufacturing. You should choose a simple manufacturing methods there and consider all the DFM guidelines there. So with that, we have completed our main topic here. I hope everyone understood this. And if you like this video, just hit the like button, share this video with your friends who need it. And if you want this type of the videos, just subscribe to my channel. Thank you so much, and we'll see you into the next one. Bye bye.